Hello, students. In this 14th session of quantitative decision tools, we shall get to know about standard deviation, what it is all about, and the formulae that is used in its calculation. The structure of this video would be starting from learning objectives, the session outcomes, introduction to standard deviation and its calculation, later the summary and the references. So, the objective of this session is to understand the concept of standard deviation and also its calculations. The outcome is the student shall be able to understand the concept and also the calculation part of standard deviation. So, coming to the introductory part, Carl Pearson introduced the concept of standard deviation in way back in 1893. It is the most important measure of dispersion and it is widely used. So, this standard deviation is a measure of dispersion and it is widely used. Standard deviation is the square root of the means of the squared deviations from the arithmetic mean. It is also called root mean square standard deviation or mean error or mean square error. It is denoted by Greek letter sigma. Coming to the calculation part, in ungrouped data, there are two ways. One is deviate by taking deviations from actual mean, and the second method is taking deviations from the assumed mean. Now we shall understand how to calculate standard deviation from taking deviation from actual mean. The first step is find out the actual mean. So we have already said how mean is calculated, that is sigma x by n. We will find out the actual mean in the first step. In the second, we find out deviations. Here, deviations from mean, d is equal to x minus x bar. In the next step, we square the deviations, that is we after calculation of d, we calculate d square and we take the summation of d square, that is sigma d square. And in the first step, we divide sigma, that is the sigma d square calculated in step 3 by the number of observations, that is sigma d square divided by n. Finally, apply the formula, that is square root of the quotient is standard deviation. Standard deviation is equal to square root of sigma d square divided by n. In the second method, that is deviations taken from assumed mean, here we don't go for the calculation of actual mean, instead we calculate the assumed mean, that is one of the observation is assumed to be as mean. And the second step, we calculate d by using the formula d is equal to x minus a. Later we take the total of deviations, that is sigma d. We square the deviations in the next step, that is d square, and take the summation, that will be sigma d square. Finally, we'll apply the formula standard deviation is equal to whole root of sigma d square divided by n minus sigma d by n whole square. Coming to the calculation part of standard deviation under discrete series, there are again two methods. One is actual mean method and assumed mean method. In actual mean method, the following steps are followed, where in the first step we calculate the mean, and in the second we find out deviations, d is equal to x minus x bar, and next step we square the deviations, that is we calculate d square. Next step, we multiply d square with frequency, that is we get fd square, fd into d square. Then take the summation, that is we will get sigma fd square. Finally, we'll apply the formula standard deviation is equal to whole root of sigma ft square by n. Here you have to be careful, n is total of frequency. In the assumed mean method, we don't go for the calculation of actual mean. In the first step, we assume a value as a mean, that is assumed mean. Next, we calculate deviations, d is equal to x minus a. The next step, we multiply f into d and take sigma fd. Next, we take the deviation square deviations, that is f into d square. Multiply the square deviations with respective frequency and take the total sigma fd square. And finally, we'll apply the formula whole root sigma fd square by n minus sigma fd by n whole square. In the third set of data, that is grouped data continuous, in the grouped continuous series, the method of calculating standard deviation is almost the same as in discrete series, but mid values has to be calculated. The step deviation method is widely used. So just like we discussed in the discrete series, the same method will be adopted in the group data, but here most of the time we follow an additional method, that is the step deviation method. The various steps that are inculcated in step deviation methods are as follows. First one is we find the mid values of each class, that is we by adding both the limits and dividing by 2. Later we assume any one of the mid value as mean, and we find out deviations, d is equal to m minus a. In the next step is we take the step deviation, that is d dash is equal to m minus a whole divided by c. In the fifth step, what we do is we multiply the d dash with the frequency and take the summation, where we get sigma f d dash. Later we square the deviations, that is d bar, and you will get d dash whole square. Now we'll multiply the d dash square with the frequencies and we take the total, where we get sigma f d dash square. Later we apply the formula standard deviation is equal to whole root of sigma fd dash square divided by n minus sigma fd dash by n whole square into c. The summarizing session says that standard deviation is the best measure of dispersion, and it is the square root of means of the squared deviations from the arithmetic mean. So we take deviations from the arithmetic mean, later we square it and divide it by the number of items, that is nothing but mean. So we take a root of that, we get standard deviations. So these are the references that I have used to prepare this. Thank you one and all.